I decided to speak about this triadic logic left by Peirce in a short manuscript because I have very recently studied this manuscript, and I think that the analysis is very interesting. I decided to share with you. It's not so difficult from the logical point of view, but I think that it is a precious manuscript, not well studied until now. Okay. Let's see. Only to recall, Charles Sanders Peirce wrote prolifically on philosophy, mathematics, logic, probability, statistics, astronomy, meteorology, geography, experimental psychology, economics, engineering, linguistics, and the history and philosophy of science, much of it unpublished to this day. Approximately 1,650 unpublished manuscripts, totaling over 100,000 pages, mostly still unpublished except on microfilm. It is well known, all the things I will mention will be connected to the end of my talk. It's very well known, Peirce's classification of sciences. He classified the science into three types: sciences of discovery, sciences of revision, and practical sciences. For him, among the sciences of discovery, the first one is mathematics. For him, the first one, because he claims that mathematics is the only science that doesn't need phenomena. Mathematics can be only an abstract part of sciences. The second science of discovery is philosophy. And in philosophy, the first subscience, in mathematics, the first subscience is logic. And he claims that logic needs mathematics, not vice versa. But the second science of discovery is philosophy. The first one inside philosophy is phenomenology. And then come the normative sciences. The three normative sciences for Peirce in philosophy.
I'm sorry, now we can see only the first slide. Is it okay?
No, yeah, it's okay.
It's okay, sorry. Okay.
It's not okay. The first normative science is aesthetics, the second one, ethics, and the third one, logics. So logic appears as a sub-science in mathematics and as the third normative science in philosophy. For him, logic is the art of devising methods of research, the science about drawing conclusions necessary, and the formal semiotic, that is the formal semiotic, the formal study of science in the broadest sense. Logic for him is this. He began writing on semiotic or semiotic for him in the 1860s, when he considered his system of his very famous system of three categories. In 1867, he presented a paper outlining a theory of education involving three universal categories applied throughout his work for the rest of his life. These three universal categories are firstness, secondness, and thirdness. Peirce's works in pure mathematics were in formal logic and foundational areas: linear algebra, matrices, various geometries, topology, graphs, the four-power problem, and the nature of contiguity. In 1860, he suggested, this is unbelievable, I didn't know this. In 1860, he suggested a cardinal arithmetic for infinite numbers years before any work by George Cantor. In 1881, he showed how Boolean algebra could be done via a single binary operation, anticipating Schaeffer's connectives by 33 years. In 1881, he introduced the axiomatization of natural number arithmetic, a few years before Dedekind and Peirce. In his paper, he mentioned Peirce and thanked Peirce for their fruitful correspondence. And Peirce gave the first purely cardinal definition of a finite set and of an infinite set, much before Dedekind. He presented in 1881 his definition of a finite set and of an infinite set. The infinite set as a set that can be put into a one-to-one correspondence with one of its proper subsets, exactly as we nowadays study and teach. In 1885, he distinguished between first order and second order quantification and proposed the first axiomatic set theory, anticipating Zernello by about 2 decades. Peirce assumed infinitesimals and worked alone on the mathematics of continuum. He was one of the founders of statistics, claiming that science achieves statistical probabilities, not certainties, and that spontaneity, absolute chance, is real. Yet, in the area of mathematical logic, Peirce is one of the most important forerunners of the algebraic tradition of logic, having considered the theory of relation algebras. Peirce's works on the subject were published from 1879 to 1903, and his work was essential for the foregoing development of the calculus of relations as an algebraic theory. Relational logic, in special Peircean ideas, have been applied in abstract analysis, lexical theory, computer science, and economics. His research led him to introduce a more general formalism containing quantifiers and individual variables, which can be seen as a primitive version of the first order logic. In 1975, he visited my university. I was a student, the University of Campinas, invited by Aida Rudder and Newton da Costa. Aida Rudder organized that my university was only 9 years old, and Aida Rudder organized then the first logic meeting at the university. During the meeting, Tarski presented some lectures, a series of seminars, which are today digitally accessible, and because they were recorded in video and they are preserved in the historical archives of the Center for Logic, Epistemology, and the History of Science of Unicamp. Here is the address of these historical archives. We as a previous PhD student, after more than 10 years working on the film, we published this book, Alfred Tarski, Lectures at Unicamp in 1975, a bilingual book. I think that Elena has a volume of it. And here it was published by Unicamp University Press and Coleção Clé by Centro de Lógica. We showed that we presented a very good introduction on the subject because Tarski left 3 or 4 open problems, more or less open until today. And in the book, we presented a general introduction for the subject in order to understand Tarski's lectures. In the lectures, Peirce was considered by Tarski to be the creator of the calculus of binary relations. In the book, Subitani, Viana, and I, we consider what seems to be the most mature version of this calculus, called by him the logic of relatives, and introduced it in 1883. Thus introduced the method of truth tables in 1885, almost 2 decades before Russell and Wittgenstein. Here is the book published by him on the algebra of logic, a contribution to the philosophy of notation. We can see that we can find it in the collected papers by Peirce. A sketch of the use of truth tables for two-valued logics appeared in a manuscript dated of 1900. In fact, we used to think that Wittgenstein and also Russell were the creators of truth tables, but it was Peirce. And nowadays, it is known a correspondence between Peirce and Russell, where we can find Peirce introducing the truth tables to Bertrand Russell. We may attribute to Peirce the pioneering creation of the method of truth tables and the conception of the functional derivative analysis of the propositional calculus. Here, I will analyze a manuscript that highlights Peirce's pioneering role in the use of truth tables, and that puts him among the precursors, the forerunners of representation in logic and of non-classical logics in general. In a manuscript dated February 17, a manuscript written between February 17 and 23 in 1909, found in his famous logic notebook. This presents in matrix form the logical basis for a three-valued propositional system, anticipating by more than 10 years the many-valued systems introduced in 1920 by Jan Lukaszewicz and published in 1930, and annual post systems introduced in 1921. Here is a photo of the manuscript. To the right,
we still can see only the first slide.
Is it being shared?
Oh. Yeah, we can see your slides. Try to change the slide. Yeah. Now we can see the new slide. Yeah.
Okay. Here I spoke about that he wrote proficuously the classification of sciences when he began writing on semiotic. His works on mathematics, the various areas in which he worked, when he introduced a cardinal arithmetic before Cantor, when he introduced the only binary operation for Boolean algebra, anticipating Henry Scheffer, when he anticipated Dedekind and Giuseppe Peano axiomatization of natural number, and Zermelo axiomatization for set theory. In 1886, he saw that Boolean calculations could be carried out via electrical switches, anticipating Claude Shannon by more than 15 years. He devised existential graphs, a diagrammatic notation for the predicate calculus. He assumed infinitesimals. He's considered the father of statistics, and he is one of the most important forerunners of the algebraic tradition of logic. Then I spoke about his works on algebraic relation logic, about his visit to Campinas. Here is Aida Hood and Newton da Costa, who invited Tarski for his visit. It seems that this was his last visit, the last trip by Tarski from the United States to a foreign university. His lectures are recorded and digitally accessible preserved in the historical archives of the Center for Logic, Epistemology, and the History of Science. Here is the address. And we have published a book after more than 10 years studying and working on the films, with the films. We have the book with an interesting and long introduction on the subject. And we, in the book, consider what seems to be the most mature version of Peirce's calculus, called by him the logic of relatives, and introduced in 1883. He was the creator of truth tables in 1885 in a paper published that is available in the collected papers. We know that he maintained letters, a change of letters with Russell, and Russell knew about Peirce's tables, truth tables, and we may attribute to Peirce the pioneering creation of the method of truth tables and the conception of the functional veritative analysis of the propositional calculus. Okay, we will analyze a manuscript that highlights Peirce's pioneering role in the use of truth tables, and that puts him among the precursors of representation in logic and of non-classical logics in general. This is the aim of my talk. In a manuscript dated February between 17 and 23, year 1909, that is in this logic notebook, Peirce presents in matrix form the logical basis for a three-valued propositional system, anticipating by more than 10 years the many-valued systems introduced by Jan Lukaszewicz in 1920 and published in 1930, and by Emil Post introduced in 1921. Here are the three pages of the manuscript. To the right, you have the first one. No, to the right, we have the last one. To the left, the first one, and the second one, in the middle. It is very difficult to read the manuscript. It is available in the collected papers, published with Peirce manuscripts. It is very difficult because the letter is difficult, it's very small, and a lot of information you have to look for and to discover what he wrote and what he probably intended to do. Here is the first page, the second one, and the third one of the manuscript. Okay, this manuscript remained unpublished until 1966, when it was published and analyzed by Max Fish and Turquet in their art paper, Peirce's Triadic Logic, published by the Transactions of Charles Peirce Society. To the values V, verum, and F, falsum, of classical logic, Peirce adds a third truth value, L, defined by him as the limit value, which corresponds to an indeterminate value of truth. He doesn't call indeterminate value, he calls limit value. Peirce considers two types of unary operators. I'm calling negations. Total negations denote two total negations denoted by him with this sign, these accents. These total negations transform all truth values. And two types of partial negation, with he noted them by these signs, that transform only some of the truth values. Here are the tables. They are written in the manuscript. To the values V, L, and F, the first total negation attributes the values F, V, and L, and the second total negation takes V to L, L to F, and F to V. See that all the values change their values. The other tables correspond to his partial negations. The first one takes V to F, F to V and L to L. And the other one takes every one of the values to the middle intermediate limit value L. We are in the manuscript, he deals also with other unary connectives that he in fact did not introduce, but we can define two new negation, two new unary operators. I'm denoting them so, and the two corresponding tables are this one. And so it's impossible to know everything now, but I'm only claiming you what he did. And so he introduced 6 unary operators. I'm denoting them to facilitate by N1, N2, N3, etc., and 6, interpreting them as kinds of negations. And so we have, relative to the 3 truth values, we have 6 negations, 6 unary operators. Then he introduces in the manuscript 6 binary logical operators, but he introduces the 6 operators by pairs, phi and theta, phi and theta, psi and zeta in Greek letters, omega and epsilon. They are pairs of binary operators introduced in the papers. He doesn't discuss this. He obtains results and writes results. Let's see. An operator O star is dual of an operator O relative to a given negation N if and only if for any formulas X and Y, the dual operator applied to the formulas has the same truth values as the previous operator applied to the negation of the formulas with the negation. Think what we know about classical logic. Disjunction is dual to conjunction relative to classical negation. This is a particular cases that we can see in the manuscript for a special pair of connectives and a special negative among the 6 unary operators. 2 sets S and S star of pairs of logical operators are said to be dual relative to a given negation N if and only if the elements of S are respectively dual of the elements of S star relative to the given negation N. I will present some examples. It will be very easy for you. And the matrices introduced by Peirce obey the following rules. The members of each pairs of operators, recall we have 3 pairs of binary operators. The members of each pair constitute dual operators relative to a particular type of negation. And each pair of sets, that means every 2 pairs is dual with regard to another pair of sets relative to a certain type of negation. Let's see. The matrices introduced by Peirce are related one to another by negation connectives, forming a symmetric system through dualities. According to these observations, to this duality of operators, we have, for instance, that the operators of the set phi and theta are dual relative to negation N5. The operators C, zeta, I'll show again, I'll show following, are dual relative to negation N6. And the operators omega, epsilon are dual relative to negation. Let's go here. We have 3 pairs of binary operators. The first pair, one is dual to the other relative to negation, one of the negations. C is dual to zeta relative to another negation, and omega is dual to epsilon relative to another pair of negation. The first one, considering the pair phi or phi in English and theta, one is dual to the other relative to the negation and 5. What have we to do from the logical point of view? I have a table, and he wrote this table in the manuscript. I calculate the values for x, phi, y. I have the result. And I calculate the table for n5 applied to n5x, theta, n5's y. I construct the table and have here the result. We compare and see that they are, nowadays we say they are equivalent formulas. We see that the result of the truth table is the same, and so phi is dual to theta relative to the fifth Peirce's negation. For the second pair, psi and zeta, they are dual relative to negation n6. We prepare the table for psi and for zeta, and you see that the table is exactly the same. The results are exactly the same one. I have to run. For the last pair, we also see that omega is dual to epsilon relative to the negation n3. Again, let's see. According to the duality of sets, we have that the pair phi theta and psi zeta are dual relative to n3. Phi theta and omega y are dual relative to n6, and psi zeta and omega y are dual relative to n5. Let's see only one example. Let's see that phi theta and omega y are dual relative to n6. We have to see that phi and omega are dual relative to n6. Here is the table. It's very easy for you to prepare the table. And we also see that theta is dual relative to y, is dual to y relative to n6. And so we have that phi theta and omega y are dual relative to n6. And we could make the calculus for the other dualities. Let's go. Let's go. Observations. I studied the connectives and negation n3. Negation n3. Let's see negation n3. Let's recall negation n3. Here is n3. V goes to F goes to V, and L maintains L. Negation n3. Let's go. Negation n3 corresponds to the basic negation of Lukashevit's three-valued calculus, of Howden's logic of nonsense, of Kierkegaard's logic, of Dotaviano and da Costa J3, Sete and da Costa's P1, and Asenjo-Priest logic of paradox LP. Although the table corresponding to the negation N3 is the same in the aforementioned logical systems, the meaning is different in these systems. In some of them, the set of distinguished values is V, only one distinguished true value, for instance, in L3. But in other systems, the set of distinguished values is VL, as for instance, in J3, P1, and the logic of paradox LP. The other negations, the negation N4, is the tertium function of Slupecki, introduced in 1936. The negations N1 and N2 are exactly post-cyclical negations, and N5 and N6 are auxiliary operators introduced by definition. Relative to the binary operators, the operator theta is the disjunction operator of L3, J3, P1, LP, posts and kernel logic. Zeta is the conjunction operator of such logics. And so we have in this logic that they are dual. The operator Y is classical disjunction operator, Bosch-Vars connective, Kleene-Zwick alternation, and Haldan's disjunction. Omega is classical conjunction. We have to discuss a little this. Bosch-Vars connective, Kleene-Zwick conjunction, Haldan's. For this, Y and omega are dual relative to their special negation. And phi and psi disjunction and conjunction in Sobotinsky system, logic of ordinary discourse introduced by Cooper, and Belknap logic introduced in 1970. Turchetti studied Peirce's triadic logic in a series of papers published in 67, 69, 72, 76, 78, and 81. Turchetti, in his paper of 69, claims that for Peirce, the tables of logical operators and negations are requirements for a functionally complete logic. Here is Turchetti's papers. Until now, I couldn't access the paper because I would like to study and to understand Turchetti's proof, because it's not easy to prove that a logic is functionally complete. But what do you have? I decided there are some papers, very recent published, that show that this manuscript, this triadic logic, because it's not a logic, Peirce only presented a set of two tables, but he wrote triadic logic. And there is a very recent paper claiming that depending on the choice of the distinguished truth values, we can obtain paracomplete logic or paraconsistent logic. But no, I have not found in the literature papers where they show how to obtain the logics. They discuss that the negation is, for instance, Lukashevich negation. Another paper shows that the negation is exactly J3 negation, but they don't show how to introduce, for instance, the conditional, the implication in these logics in order to show that we can, in fact, define all the other connectives in the other many-valued logics. And so I decided to look for this universality in Peirce's three-valued matrices, and I decided to study Lukashevich logic L3 and Ottaviano and Da Costa's J3 that are iconic system, three-valued paracompleted system, and three-valued paraconsistent system. Here are the reference for Lukashevich system and for the Ottaviano and Da Costa system introduced in 1971. I will ask you, may I go until 19? Because I'm asking, are you hearing me?
Yeah.
May I speak some more 15 minutes?
You have 20 minutes.
Yeah. The propositional calculus L3 was introduced by Lukashevich and Peirce in 1930, published by the matrix. It's all known. We have three truth values, but one distinct value. And the calculus was introduced by matrix, having only two primitive connectives. A negation, that is the N3 negation by Peirce, introduced several years before, and his implication was introduced, their implication was introduced by Lukashevich by this matrix. The system introduced in 71 by Ottaviano and Da Costa was introduced also by a matrix with three truth value, but with two distinguished truth value, and by three primitive connectives: negation, and modal operator, and disjunction. The matrix introduced are this one. The matrix for the negation is the same one, but with a distinct meaning, because L is also distinguished truth value. And here we have the disjunction, and here this operator that is a kind of possibility operator. Then we spent a lot of time, several days and nights, in order to discover how to define Lukashevich implication and J3 implication by using only the primitive connectives introduced by Peirce. And so we define it in J3. In J3, J3 has negation, a modal operator, and disjunction as primitive connectives. And the implication is introduced by definition. And its table is distinct of the table for Lukashevich implication. Then we consider, by considering Peirce's matrices in L3, we saw that both L3 and J3, they can be given by these matrices using the same primitive connectives, two negations and the binary connective theta. But here we have distinction truth value. We have to define, by using Peirce's matrices, two distinct connectives that correspond to necessity and possibility. They are definable by using the connectives N2 and N3 basic and the operator zeta that may be defined dually from the primitive connective theta. And so we have two auxiliary defined connectives, and then we could define the implication L3 by this formula, by using only the primitive connective N2, N3, and theta. And here we have the J3 implicative connective defined only by using the primitive connectives introduced by Peirce. And so we could reproduce Lukashevich implication by our definition, and we obtain exactly the table introduced by Lukashevich. Doing the same calculus for Ottaviano and Da Costa's implication, we obtain the final table, and it corresponds exactly to the table originally introduced in the paper by Ottaviano and Da Costa. And then we decided to analyze the principle of non-contradiction and the principle of excluded middle. And it was very surprising. We saw that both principles, non-contradiction and excluded middle, are not valid in L3 relative to both primitive negation. We knew that it is not valuable to the Lukashevich primitive negation, but here the principles are not valid relative to our two primitive negation. The principle of excluded middle is valid in J3 relative to negations N3 and N2, but the principle of non-contradiction is valid in J3 relative to negation N3 and is not valid relative to negation N2. Here we prepare the table. Here we have the principle of non-contradiction. It's not the case X and not X relative to N3. We see that this principle is valid in J3, but not valid in L3. The principle of non-contradiction relative to N2 is not valid in J3, not valid in L3. And the principle excluded middle is valid in J3, not valid in L3, valid in J3, but not valid in L3. And then we studied the ex-falso circuit or quadrivium that characterizes paraconsistent logics. And we saw that the principle is valid in L3 and is not valid in J3 relative to negation N3, but it is not valid in L3 and not valid in J3 relative to negation N2. Here are the tables. This means that Lukashevich's logic is paracomplete relative to both negation N2 and N3. But Lukashevich logic is also paraconsistent relative to negation N3. And recall that the first papers and book by Lukashevich, he claimed against the principle of non-contradiction. And the principle of non-contradiction is not valid relative to N2 and to N3 in L3. And so from a sentence title point of view, Lukashevich three-valued logic, in which the principle of excluded middle is not valid for him, is also paraconsistent from a certain point of view. Here we have the ex-falso circuit quadrivium is not valid in J3 relative to negations N3 and N2, because we have a value false in the table. Continue. L3 is paracomplete relative to negations N3 and N2. J3 is not paracomplete. L3 is not paraconsistent lato sensu relative to negation N3, but L3 is paraconsistent lato sensu relative to negations N2. J3 is paraconsistent lato sensu relative to negations N3 and N2. All three-valued logical systems can be introduced through Peirce's three-valued matrices, and we conjecture that this result may be combinatorially realized from any valued system with a natural number. What could have been the goals and motivations of Charles Peirce when considering his three-valued matrices by calling them a triadic logic? Various Peircean scholars have discussed Peirce's possible philosophical motivations and have especially discussed the meaning of the third truth value L. We intend only to make an analysis relative to the relevance and the originality of Peirce's system in face of the development of logics during the 20th century and in this 21st century. Peirce dared for the first time in the history of logic to challenge the principle of bivalence, conjecturing a system with three truth values. He dared to discuss philosophically the possibility of the non-validity, even if only for specific propositions of the principle of the excluded middle and of the principle of non-contradiction, before the works of Brouwer, Lukashevich, and Post, and before the creation of many-valued logics, modal logics, paraconsistent logics, relevant logics, and other types of logics, said non-classical. His thought about universally quantified propositions, vagueness, indeterminacy, and modal propositions. He dealt with problems pertaining to the mathematics of the continuum and dealt with the meaning of the frontier elements of structures and of systems. It is already notorious in the manuscript, the passage about the ink blotch at the end of the manuscript, which the scholars have interpreted as an example of Peirce about propositions to which it would be attributed the truth value L. I claim that we consider interesting that many commentators have agreed that for those frontier elements of the block int, the principle of excluded middle would not be valid. But for us, from a logical point of view, Peirce also expresses the possibility in these elements of the non-validity of the principle of non-contradiction. Peirce not only challenged in his manuscript the principle of bivalence, but also challenged the unrestricted validity of the principle of excluded middle and the principle of non-contradiction. At the end of the manuscript, Peirce seems to consider the possibility of distinct sets of distinguished truth values. I have not seen this in any one of the commentators of Peirce's manuscript. He writes at the end exactly with a different distinct letter. He puts a worked V and puts equal to VL. And he writes F, putting in this set F and L. And so I understand that he was conjecturing the possibility of more than one distinguished and non-distinguished truth value. Claim at the end, Peirce claims that thus the triadic logic does not conflict with dyadic logic. It seems that depending on the choice of the distinguished truth values and of the interpretation of the adequate set of connectives, he's claiming that we could generate classical logic from his triadic logic. And he concludes in the manuscript that triadic logic is universally true, but dyadic logic is not absolutely false. It's only limits. Okay, for Bertrand Russell, Peirce was one of the most original minds of the later 19th century and certainly the greatest American thinker ever. Karl Popper viewed Peirce as one of the greatest philosophers of all times. He conceived with his set of unary and binary operators and his pre-valued matrices all of the possibilities of logical connectives for all three-valued logics that would be created and developed from the beginning of the 20th century, paracomplete, model, and paraconsistent logics. Perhaps, on our understanding, the set of truth values being ternary has a relation with his triadic style of science and his triadic theory of universal categories, and perhaps with the elucidation of his concept of frontier of systems. We have published a book in Portuguese, you know the book, about on the history of paraconsistency in the Western thought, and we are finishing an extended English version of the book that will be published by Santesi Library, whose title will be Illuminating Contradiction, from Heraclitus of Ephesus to Stanislau Jaskowska and Newton da Costa. And very, very recent, nowadays, we have just added a special chapter, a special section in the book, considering Peirce on Peirce's manuscript. I have just presented you the section, almost more or less the section of the book, and claiming that Peirce is also one of the forerunners of consistent logic. And to finish, Peirce foresaw a path of development that helped pave with concepts, notation, methods, and ideas much beyond the traditional boundaries until then of logicity. For us, thus paved the way for the development of logic in the 20th century, especially for the creation and development of non-classical logics, particularly of paracomplete and paraconsistent logics. Spasiba.